Okay, we're going to walk through chapter 4 of our text, which focuses on unit testing and refactoring, and discuss this material. There's some really interesting design patterns in here and some ideas from unit testing. So let's get started. So the first thing we're going to do is talk about unit testing. You should have seen unit testing before, probably in the Java world with like the JUnit testing. In our learning resources, I post some links here. This is a quick review of unit testing from Java. So it talks about the kinds of testing, unit testing, integration testing, system testing, and that sort of stuff. We cover more of this in the following course, the quality assurance course, which just focuses largely on testing. But in this software design, we're just talking about unit testing. Talks about good ways of doing unit testing and some ideas about unit testing. But then it talks about, and this is important, the JUnit stuff from Java and how we set up unit tests in Java and run them from the IDE. It goes on with some other unit testing methods, and then it talks a little bit about test-driven design and has some interesting comments and videos about test-driven design here. And we'll mention test-driven design again in a sec. So that's this one. And then there's another link here to another thing about unit testing that I find useful. Just again, going some more background about unit testing and test-driven design. Okay, back to the text. So the text uses this arrange, act, assert structure for unit tests, and we'll structure all of our tests this way. This is a common way of setting them up. Other people set them up basically the same way but use different terminology. Given, when, then is often used too. But again, the structure of the unit tests are almost always the same. What we label these three parts differs a little bit. So the first thing we do is have to arrange the preconditions for the unit test. Then we're going to perform the act we want to test, do what we want. And then finally, we're going to assert the expectations here. So a typical unit test will look like this. Here we're testing out an account class. And again, since this is unit testing, it usually focuses on a single class and the methods in that class. We have a public class for the unit tests. So this is called the account test class because it's testing the account class or object. And then we'll have a number of tests in this class, and we try to use long descriptive names in them, adding transaction changes balance and things like that, so that when we just see this, we'll know what test it is rather than just test one or test two. It's really nice to have long descriptive names. And here's our arrange, act, assert. So again, arrange, we need to, if we're going to set up or test out the account class, we need to create a variable of that, an object of that type. So we create an account. We do what we want. This is our action. Here we're adding $200 to that transaction. Now the M here is because we're working with decimal numbers, a decimal type. And by default, if you say 200, it's an integer, or 200.1, it's a double. So just to make this constant, default to a decimal, we put M. Decimals are usually used for money, and M is a short kind of moniker for money. It can be a capital M or a lowercase m. And then we do an assert. This just says we want what the result should be. We want the account balance. Now we're going to go grab the account balance after we've added this money to it, and it should be equal to 200. And notice we are using R equals here. Now you may have seen the assert class again in your Java 2 class or other classes. This is just often used in testing to just make sure we that this is going to work, or that this is true. I have a posting here to the assert documentation. From Microsoft. And again, this is the C# version of assert, but like Java has its own assert and stuff, and they're very similar. One thing we have to watch is the types. There's R equals, which we can check if two doubles or strings or objects are the same value, and that's what we'll use a lot. We have to watch compared to, there is an equals operator down here. equals, and that just determines if two objects are the same. We don't want to do this. This means two objects are identical, not equal to each other. I don't know if that makes any difference, but you can have two objects with the same values, but they're not identical. They're not the same memory locations. The dot equals will actually check if they're the same memory location. So we avoid that. We want to use r equals or r not equals when we're comparing things. But there's also ones, there's true is false, is null, that sort of stuff. So there are some other asserts we can do here also. Okay. So to kind of get used to running these tests and setting these up, we'll use a unit test runner generally. Most IDEs have that, and Visual Studio certainly does, and so we want to use that and set that up. So a good way to try this, do this, is actually try it out. In the source code, there's this Chapter 4 Test-Driven Design Initial Implementation. I suggest you just grab that either from the source code you downloaded at the beginning of the term, or else you can just grab this zip file and open it up in Visual Studio and just try out some things. So here's our it opened. Here's account tests, and here's the customer accounts with the account method. So this is the method we're going to try to test out. Right now, when you create an account, it sets the balance to 200. When you add a transaction, it does nothing, and then it has a single property, here a single thing. It keeps track of the balance, and there's a get and the set. Interesting, they make the set private so that we can only set that in here. Outside, you have to use one of these other methods to add or remove things from the balance. So this is the account class we're going to test, and this is the account tests we're going to work with and use. And we'll look later in how to add these account tests to a project like this. It's just adding a new project to your well, I'll just show you right now. So if you want to add a new project, a new test project, you would say add a new project. Usually we've been adding like C# stuff like class libraries or Windows Forms applications. There's a test area, and we'll be just using the unit test. You'd give this some name for often after the object you're testing. I'll just leave it as what pops up here. One thing you have to watch out now, if we're going to be inside this unit test area, there'll be a sample test for us to use. But if we want to reference like the account class, we may have to make sure we add that reference. So under references, we'd have to add a reference to like the customer accounts. And then once we add that reference, then in this test object, we can create a customer account and work with those. Okay. So, and then you can see this test classes or projects have a little test tube next to them compared to C# or other projects. So that's how you can tell the difference. Okay, I'm going to delete this one I just created. Okay. So let's look at our actual tests. So we looked at accounts and we looked at our tests here. We're creating a new account, we're adding some transactions to the account, and we're asserting that the account balance is equal to 200. Now we can run this test. To run this test, we go to test, run, all tests, and it'll run all the tests in all of our test projects here that we have. Now it should bring up a little test display or interface here that'll show us how we're doing. First it has to build some code here. It should be building code down below, and then it should be popping that up. Okay, and here's our tests, and here's the test names, and this is why we often want good descriptive names, because we only see the test name here, and then we either get a check or an X if we passed or not. So we passed this test. So now we can add some other tests to this. I'm going to close this again for now. Now when we add tests, we have to make sure that the class is labeled test class and each test is labeled test method there. So generally a nice way of doing this if you're adding tests is just to copy that whole thing and paste it down. So we'll add another test. Like one that would be nice is when we create a new account, the balance should be 0. So we'll name it somehow like that. A new account has 0 balance. Okay, so our range is going to be saying we're going to create a new account. The action is we're not actually going to do anything here. And the assert is that our account balance is going to be 0 when we're done. And again, we're using this M because, again, if we look into our accounts, balance is a decimal, so we have to be providing decimals. And if we don't have that 0 there, it should give us an error. Maybe it's not going to do that. Yeah. Okay, so yeah, I forget. Sometimes it'll flag errors here if it can't do the conversion, and sometimes it'll be okay if it can automatically do the conversion here, whether or not you put the M there or not. So now we'll run this test. Well, I guess we'll run all the tests again. And now we've got an error here that we've got a problem with our test class. And again, we can go look at that. We'll see some. We can also look in our accounts class, and there'll be now these little symbols here saying that these methods are called in tests that failed. We don't know where it was, but both of these methods are part of a failed test. So we want to generally then fix, we can see something went wrong here, so we want to walk through the logic and see. So we created an account, set its balance to 200, and then we did. So obviously when we create an account, we want to set the balance equal to 0. You should have no balance to start with. And then we can run our tests again. Now we think that we fixed the one that this new account has 0 balance. Now that passed, but now this is causing this other test to fail. And so this is kind of part of test-driven design here that we'll get to in our text in just a sec. So now we have another test, and we can look at that. Adding a transaction changes the balance. So we create a new account, we add 200 to the account, and then we check if the account balance is equal to 200. So that's not working when we create an account, its balance is 0, but then we have nothing here when we add the transaction. So we want to do something like balance equals the amount. And we might, no, that's not correct. We really want to do a plus equals here, but this will actually get this one test to pass. So again, just because your tests pass doesn't mean all your code is correct. So we may want to be careful on what tests we add or create here and try to test different conditions. Let's jump back to the textbook now. Okay, so it walks you through, again, some of this unit testing stuff. And then introduces this concept of test-driven development. This is when we create the tests first for like a user story that we want to do, and then the test fails, and then we're going to work on the test until we get it to succeed. There's a process called red, green, refactor, and the idea is that initially when you run your test, they'll be red. Then they'll pass the test, they'll be green, and then when they're green it's working, but that doesn't mean your code is optimal. So then we'll do what is called refactoring. We'll try to look through and try to optimize our code and keeping all the tests passing. I will point out one confusing thing I found with this chapter is they use this acronym SUT. That's the software to be unit tested, or the item to be unit tested. So they often talk about that. I haven't seen that before except in this textbook, but so in our unit tests, this is just the item to be unit test, and sometimes they use variables of that, name that for other variable names, but that's how your textbook handles it. Okay, so test-driven design. I've had a number of alumni out there in the field. I'd be interested to hear if any of you have experienced test-driven design or worked under it. But I've had a number of alumni in the field come back and tell me the importance of test-driven development and how their companies use it extensively. So it'd be interesting to see if other people are using it. Okay. So again, it walks you through this test-driven design, creating a new test class like we did. and then modifying this. And then they add a couple more tests. So here's one. Let's just grab this test method here and put that in. Adding 2 transactions changes, gives it the sum. So now I'm going to go back into my test class. And again, so I'm in one test class and I have a number of tests here. They kind of spread out with this format here. Often when you get doing these tests, you'll get rid of some of these comments or move the comments over here and shrink these tests down a little bit so they don't take as much speed. But here's our adding 2 transaction creates a sum of the balance. So we create an account, we add a transaction account, and then we add, I think this should be down here under 2 actions, but some people should like the idea that you should only be testing out 1 action, but here we're really doing 2 actions and 1 assert. Now there's lots of discussion on can you do multiple tests or multiple asserts in one area. So could you create an account and then check if the balance is 0 and then add a transaction and combine all these 3 tests into one? And the general idea is that you should try to make specific individual tests that test individual things so that when that test fails you can look and go there and see exactly what failed. You don't have to go through a big long test that tests 20 different things and figure out what actually didn't work. So that's why we're using different tests here, and then once we create these tests they'll be run automatically for us and we don't have to worry about them anymore. So we're adding a transaction of 50 and a transaction of 75. Now we can run these tests, see which ones failed. And again, a new account has 0 balance, that succeeded. Adding a transaction changes the balance, that succeeded. But adding 2 transactions failed, so we can go look at that. So again, in our account, we add a transaction. We're setting the balance to the amount. We're not doing a plus equals amount, which is what we should be doing. Make that change, run our tests again. So now we've got some red over here. Hopefully now we'll be all green and ready to go. So we're all green and ready to go. We can go on to the refactoring stage next. Okay. So again, we walk through the solution, doing the plus equals here and showing that. Now we get into more complicated tests. Right now the setup here was relatively easy because again the object we're testing was relatively easy and isolated. It was just a count class without anything else there. But sometimes it gets much more complicated. So here we have a model-driven controller kind of interface here. We've got a database access repository here that's storing the account information out into a storage location like a database of some sort. We have a user interface, a controller here that's grabbing the account information and probably feeding that to a view over here, and we have some business logic in between. Here's the account class, and again this is kind of isolated. We can just test this account class by itself, but let's say we're adding an account service class here. The account service class is going to be in charge of getting the accounts from the database, creating these accounts, and then providing those to the user interface controller for us. So we've got this here, this account services, and this account services is going to be implementing an interface for use. That's how we're going to define it, is that it'll have an interface it'll implement here. And there's also be an interface here to this database access that we'll get to. Okay, so this is our setup here. Again, our accounts are going to be stored often in this database area, and we're not going to be implementing this or have this around. So this is the database access, what they call object relational mapper, here converting SQL objects into C# objects here. Okay, and we're again talking about test-driven design and the AA strategy. So we're going to create these test class account service tester, and our setup's going to get more complicated here. We can't just create an object of that type. We're going to have to do a little more complicated behavior here. So what we're going to have to do is create a fake repository out there and setting that up. So it talks about here about using fakes, or what we'll call mocks in a little bit. So we're going to create basically we're going to create a fake version of this iAccount repository so this account services can use that. It's going to go out and get an account and bring it back, but we don't have this, so we're going to fake this. So we create a fake repository that implements that interface, and all we're doing is we're going to give it an account when we create it, and then we're going to say get by name. That's the method as part of this interface. But all that's going to do is return the account. So we have to implement all the methods in this interface, but we can simplify them. And in this case, we're not going to go out to the database and search by name. We're just going to give the one account we used when we created this object. And then here's our code that we're going to use, that we're going to test out the account services. And then so here's our test. So our setup is getting more complicated. We're going to create a new account object. We're going to create a fake repository and give it this one account. So like it's kind of setting up a little mini database with this only one account in it. We're going to then create our account services, and it needs this fake repository when it creates. So it needs to know where to get the data, the access to the database through the database repository. So this is the fake repository there. Okay, once we get that all set up using our fake interface here, then we can use our account services, and they're calling it SUT. I would have preferred they called it an account service here, but they're using that, and they're going add transaction to account, and we specify the name of an account and then the amount. And then we check if the balance is equal. And so it should have added it to this account here that we passed in. We created this account, sent it to the repository, so we should be able to check that account and its balance, and it should be equal to this 200. So they go through and talk to you about implementing these with fakes, and then there's something called mocks. Now let's just look here. So there's some discussion about what's the difference between fake and mock and stub. There's these terms used quite a bit around there. So here's a Stack Overflow posting that just tries to define them, and then there's some discussions about what other people think. This is a nice one because it talks about two different responses and compares them. There isn't a consensus, but there's a fair amount of ideas about what a fake is. Fake actually is a working implementation, but takes some shortcuts. Stubs cannot answer calls made during, but just respond with anything else. So you're it just lets you perform the test, doesn't really do anything at all, the minimum amount. And a mock is often set up automatically to implement an interface. It has pre-programmed expectations, which we have. So again, but in general, when you hear the term fake or stub or mock, you can kind of think of the same thing. It's something, a fake object we're creating to implement it. So again, often when we're working on testing things out and we're saying, well, we're going to have to test this out, but this is access to this database repository, or this access this user interface, or this access this something it's going to access. So we're going to have to mock out this, fake this out. For example, if we were going to run unit tests on this account controller, the account controller works with this iAccount service, this interface here. We would have to mock or create a fake for this. So that this account controller could be tested kind of in isolation. Same here with this. We're going to create a fake or a mock of this to test it out. The book walks us through, but I think it's also useful to try to see this in Visual Studio. So why don't you open up one of these projects? Now I included the Chapter 4 mocking with fakes zip. That's also in the original thing, so let's open that up. So I'm going to go down and find the Chapter 4 mocking with fakes one, and open that up and walk you through that a little bit. So bunch of projects here. Let's just go walk through them, and again, they should map to this sort of picture. So keep that in mind as we're going through this Um, let's start with the accounts. And the accounts are stored in this domain project. So we have an account class here. Um, an account class is just like we saw it before, just as a balance, and we add it for now. This will get more complicated soon. Okay, so that's in the domain, and we have some domain tests. We don't have any actually here, but this is where we'd stick them. Then we have account services. So that's in this service class. We have account services. This is managing the accounts, going out to the database, getting the accounts, and returning. So when we create an account service, we have to specify a database connection and an iAccount repository interface, and we use that to go out and get the accounts and set those up. And with that, we have these service tests, and this is where we're looking. And so this is our account test that we just looked at, and here is where we're creating that fake repository as part of this test area, because we'll be doing this. So this is implementing this fake repository. Now in order to set this up, if we look at the references, this is going to use the domain. It has to create accounts. It's going to use a repository interface, the service interface, and services. Use all these projects, and so we have references to all those tied in here. Okay, so that's services and service tests. The service interface is just a little interface that defines the service. And again, this is this interface, so our account controller would use that interface to know what's available in services. And right now the only available transaction is to add a transaction to the account. So again, this is very limited, just to show the some minimal things how this works. We'd actually want to be able to add a transaction, subtract a transaction, check a balance in an account, and create an account, and a bunch of things like that. And we'll see some of those later on. And so that's all we have in this project. We don't have anything above that, so we don't have this user interface. In fact, we can't run this project. If we try to run this project, it'll say these are all class libraries. There's no executable. There's no user interface or main here that we can run, so we can't actually run. But we can run the tests here. So we can run all the tests, even though there's not an executable and there's only one test, and it should pass. Okay, so it's just kind of nice to see how that's set up here, and we'll be using the same sort of setup later on when we work on the assignment. Okay, so that's our setup here. Okay, and we talked about mocking. Now there are some problems with writing too specific of a test. We want to test behavior rather than implementation. So again, we often don't want to test that when we deposit something, that the result is a decimal rather than a float or something like that, because we don't care about that. Later on, they might change that value or something like that. So we just want to really worried about the behavior and be at the behavior level here. Not often people say you shouldn't need to look at the code that implements all this stuff and test all the code there. You should just be worried about the interface and how we access that. So then we go into some further tests here that we can set up. Check if an account is null. Check if the repository cannot find an account, and things like that. So we might add more accounts here. So here we're saying what happens if we create a new account service and we specify null as the repository. And one of the questions is here, when we do especially some of these sorts of things, it's not unclear what the the result of the test should be. So often these sorts of tests make us decide, how do we handle errors, and what errors should we be looking at and handling, and how should we be handling them? Should we be throwing exceptions, or should we be handling that? Is there some place to place a warning or log an error, or should we just ignore that and keep going? So we add some tests here, and we handle them. So here's in our account services, we're saying if the repository is null, we're going to throw an exception. And again, when we throw exceptions, we can add some descriptions to this, and then we can catch those exceptions later on. We're not going to go into too much detail about throwing and then catching exceptions in this chapter, but that's sometimes how these errors are handled. So we walk through this. Um, And again, that talks about this null, if your account is null, and how that can work here. So read through that. And again, it talks about like if you call a message, a method, and a method down like to the account level, the main level, and you have an exception here, you might throw that exception back up. And here you might catch that exception and then throw a different level exception up here to this class. So we might have a model for how exceptions flow through our code here. And again, this does a simple mock here and sets this up, and then looks at a simple try catch, catches one exception and throws a new exception up. And a lot of times companies will have a whole set of exceptions that are used in different areas of their software, and a predefined set of exceptions that are used. Okay, now sometimes when we run these tests, we want to be able to run them automatically a lot. MS Test has this framework for it. Now there's if we're often setting up a complicated test environment, we can create a method called with the tag test initialization, and call it like setup or something like that. And this will be guaranteed to run at the start of every test in this class. So if you're doing a lot of mock setup first, and in some areas you have to set up a lot of stuff. I remember programming once for the telephone company. We actually had to run our unit tests on large phone switches. So I had to reserve a phone switch, which was in a huge separate room for the day. And it would take me an hour or two just to set up that, get the hardware all booted up and running and everything loaded on it and run. So I always think, well, this is nice, simple setup. But for if you're not used to this, sometimes this setup seems complicated. So you can create your own little setup method if you have to do it multiple times. I'm going to backtrack just a sec. There's something we skipped earlier on when I was going through this, and that's sometimes when we're programming these interfaces and setting things up, it's hard to set up all these fakes, and so there are some environments or tools that are used for that. One that's out there is called mock, MOQ. And it will let us set up an interface. If you have an interface, it'll create a mock for that interface automatically, generally. So here, if we have this interface, we can call mock and set that up. We're not going to use that, but I just wanted to mention that it is out there, and most environments have something that often will mock interfaces for us. So, okay. So now we're going to go on to refactoring and talk a little bit about refactoring and how that works. So part of the test-driven design process is to start with a bunch of failing codes red, get them all succeeding green, but that doesn't mean your code is working all that perfectly just because you're passing a test. So then you want to refactor. So we're going to look at that here and look at refactoring. And so we're going to be changing some code and modifying it. So here's our first version of accounts. Now we're going to look at a little more complicated version of accounts that has reward points and different types of accounts, silver, gold, and platinum accounts. And for them, we'll get some different reward points every time we deposit money into our account or spend money. I don't know what kind of account this is. We'll get some reward points, and silver gets less reward points, gold and platinum get more reward points. So we're going to do that. So the first one they talk about is replacing magic numbers. So if you grab this refactoring base here and open that up, you can actually try this out and see how it works. So inside refactoring base, there's the account class and account types. Account types is just an enum of the different types. This is common in some areas. You create an object that just defines an enum, and so you can just say account types dot gold or account types dot silver to access those values. But here's our accounts, and again we have some numbers in here. These are hard-coded constants that are in here, and we often want to change those. I remember I had was working again at a company, and we had a huge code base, and one of my colleagues, his job was we were going from 7 lines of phone lines going in to 9 lines, so we had to go in, and everywhere there was a 7 in an array or whatever, you had to change it to a 9. It took them a week or so because of hundreds and hundreds of lines of code, and we have 7 days a week. We had 7 different traffic measures. We had a lot of different 7s in our code. So every time he had to write a large report defining every 7 and whether or not it should be changed to a 9 or not. So I always remember that whenever I think of these magic numbers. And if we just had used magic numbers back then, we would have saved a lot of work. Okay, so we have these magic numbers, and we can refactor them. So again, we can just declare some constants here and move these out. Now sometimes the question is, what should the constants be? So certainly I think this 2, 5, and 10, these are when we take your amount and divide it by that factor. This is the silver factor and gold and the platinum factor. But here we have 10,000 times 5 here. So we got balance divided by 10,000 multiplied by 5, and this is 10. And I don't know, is this 10,000 the same? Is this 10,000? Should these be 4 different constants? Should they just be 3 constants? This, a 10,000, a 5, and a 10, and we can reuse that constant here. So sometimes you have to ask these questions and try to look at these formulas and see what you're actually doing. And that's the reason why we want to do these, remove these magic numbers, is make it clear what these are. Also, now, do we need actually 2 numbers here? I mean, if we take a balance and we divide it by 10,000 and multiply the result by 5,000, that's really the same thing as multiplying this by 2,000 here, because it's really 5 over 10,000. So this is the same as dividing by 2,000, and I think this is the same as dividing by 1,000, 4,000. So again, we can work these out. So you can go through and test these out. In my classes, in class ones, I have the students just go through this, but the textbook actually does a pretty good job of walking you through this section to this section. So again, they define these. They use constants. They use again the 10, 5, 2. They pull out into. I think these names are a little long, and they're not all caps. So to declare a constant, we say private const, like final. In Java, it's const here, and then this is the name. But I find these too long. I just say that's silver, point cost or something like that. But those are here, and then they just use they have the balance divided by this and the balance divided by that. So they're simplifying this calculation a little bit here too. Okay, so magic numbers are one thing we often refactor just to make the code more readable and more maintainable going on. Another thing is this polymorphism that we're going to go through and work. So we're going to introduce a couple classes here and work on this. Now the rest of this chapter we're going to actually work on in the assignment. So I'm going to go over it relatively quickly, and then we're going to talk about it more in the assignment. So what we're going to have is an account base here. And then, here they have different accounts, and they all implement an abstract class, a base class here that we're going to work with. And so they walk you through setting up that base class, and then they have the different accounts. And then they create what's called a factory method. And so this is where we're going to start. We're going to implement this factory method in our assignment. So you should read through the rest of this on this factory method and how we're going to do it. I'm going to simplify a couple things in the assignment so we can get through this. Now that goes on to some more complicated code here, where they're trying to replace some different objects here and stuff. This inheritance and delegation, we're not really going to go into that. We're just going to use this factory method that they use and get that far with this. Okay, so that wraps up this chapter. A lot of stuff covered. So hope you enjoy the assignment this week.